include machine translation and NLP. So welcome, Weiqiu.
Hi everyone. I'll share my screen now. Start. Can you all see the slide? Okay.
Yes, we can.
Okay. Hi everyone. Today I'll be presenting qualitative analysis of unsupervised neural machine translation. This project was done in my internship at ISI this summer, working with John. So most neural machine translation models today are trained with supervision. We would have two parallel corpus with pairs of sentences that are translations of each other. If we train a German to English translation model, we would feed the German sentence into the encoder and then pass the hidden state to the decoder and then decode the English sentence one word by one word. The output English sentence will be compared with the gold translation in the English corpus, and then cross entropy loss is calculated to train the model. Unsupervised machine translation, on the other hand, does not use any parallel data, but only monolingual data of each language. One of the state-of-the-art unsupervised neural machine translation method is to first train a mass language model that can fill in the mass for sentences in the two languages. We then initialize the encoder and decoder of the translation model with the mask language model. Then we train a denoising autoencoder, which first adds noise to the sentence, encode it to the latent space, and then decode it back to the original sentence to match the original sentence without noise. At the same time, we also do back translation by adding noise to the target sentence, translating it to the source language using the current model, and then training the forward model by translating the generated source sentence back to the target language, and then compare with the gold target sentence. This way we have the fake parallel data. The denoising steps and the back translation steps are done iteratively, and then eventually we will have the unsupervised machine translation model. So it is imaginable that the unsupervised machine translation is hard to do. But now we can see from this chart that UNMT can be close and even surplus SNMT sometimes. Of course, if we make use of all available parallel data and monolingual data, SNMT will definitely outperform UNMT with the abundant data. But UNMT is getting some comparable results in some data size conditions. Some previous work has shown that it is usually not the case that there is a large amount of monolingual data, but no parallel data at all for a low resource language. So what we are curious, on the other hand, is that if we limit the data for UNMT and SNMT and make them have the same BLEU, are they actually the same? Do they exhibit some qualitative differences? So BLEU is a common metric that is used in evaluating neural machine translation. So we first calculate a modified precision, which is total matches of a class, and then divide that by the total predictions. And we have this modified precisions for each n-gram from 1 to 4 n-grams. And then we do a geometric mean of all these modified precisions. And then because BLEU only uses precision, it substitutes the recall with a brevity penalty. So if if the total length of the hypothesis is shorter than the total length of the reference, then it will penalize it. So this brevity penalty is multiplied with the total modified precision to give us the BLEU. And another metric we are using in this project is macro F1, which was done by TG. So F1, so macro F1 is just the macro average of the F1 score for each word. So the benefit of macro F1 is that it has the same weight for each class. So for BLEU, it will have more weights when the frequency of a word is larger. So macro F1 will focus more on the content words which has less frequency. So we have the XLM version of the UNMT model, and we have the BLEU for 3 language pairs in both directions. Then we select SNMT models to match the BLEU of UMT models. SNMT models for English, German, German, English are trained ourselves. And for convenience, we selected the closest BLEU, the system that have closest BLEU from WMT submitted systems for the share test. For English, French, French, English, Romanian, Romanian English. Surprisingly, even though SNMT and UNMT has similar BLEU scores, SNMT has much higher macro F1 scores in most language pairs. We can see clear with this this graph. So sometimes BLEU is slightly even slightly higher than the UMT for UMT. So the yellow bars are BLEUs for UMT. But for macro F1, SNMT is consistently higher. So we then want to ask, what is the qualitative difference between UNMT and SNMT? What did macro F1 find out that BLEU didn't? So as macro F1 and BLEU are both corpus level statistics, it's better to not use it on a single sentence. So here we use a maximum difference discriminator approach. So we first have the 2 corpus translated by SNMT and UMT. And then we remove 1 sentence X from each corpus. So this is the translation of the same sentence. So we calculate, we calculate macro F1 for all 4 of these. And then we will take the difference between the corpus that has the sentence and it doesn't, and the one that doesn't have this sentence. We have the delta of macro F1 for SNMT and UMT regarding to this sentence. So so if this delta is high, then it means that the corpus is better with this sentence. So it means from macro F1's perspective, this sentence is better than some other sentences. And then we take the difference between these 2 delta macro F1s again. So this this will give us the comparison of SNMT and UMT. If this value is higher, then it means macro F1 prefers SNMT over UMT. So we look at the top 10 delta macro F1 over for both when SNMT is better than UMT and the opposite. So we manually examine the top 10 sentences for each case. And on the left, we can see where SNMT is deemed better by macro F1. So bolded words are actual problems that affect translation meanings, and non-bolded words are what makes the translation different from the reference, but are not actually changing the meaning. So we can see on the left chart that SNMT has a lot of synonyms that are not essential, while UMT has untranslations, so like words that are not translated but just copied over, as well as truncations and wrong words. When macro F1 prefers UMT to SNMT, as we can see on the right, UMT still has some essential problems like untranslations and wrong words, even though SNMT has more problems. We can also take a look at the result of BLEU. When BLEU prefers SNMT over UMT, we can see in the 7th example that SNMT still messed up the active and passive relation. And when UMT is preferred over SNMT, there are some examples where SNMT has trivial problems like punctuation and symbols, like in the second and third examples. So from this analysis, one takeaway is that UMT has more issues that can be found out by human, even when it has higher automatic metric scores. Also, BLEU sometimes seem to overemphasize more trivial problems. We also look at CompareMT, which is a tool for quantitatively analyzing the differences between corpus. We can see that UMT has higher word accuracy for high frequency words, while SNMT has higher word accuracies for low frequency words. In this sentence bucket analysis, we can also see that SNMT has higher BLEU for longer sentences and shorter sentences, while UMT has higher BLEU for the medium length sentences. So the sentence length that are most common. So this could also could be how some sentences in UMT are compensating the others when evaluated in BLEU. During this analysis of UMT and SNMT, we also noticed the difference between BLEU and macro F1. So the other direction we investigated was what are the qualitative differences between BLEU and macro F1. I guess the delta macro F1 and delta BLEU from the previous slides were already confusing enough. Adding to that, we compute the delta rank between the delta macro F1 and delta BLEU. So because macro F1 and BLEU can have different scales and are not directly comparable, we first rank all the translations with delta macro F1 and delta BLEU separately, as we can see in the column B and column C. Then we do delta macro F1's rank minus delta BLEU's rank and put it in the column D. So the lower this number is, it means that macro F1 prefers SNMT way more than UMT, while BLEU prefers UMT way more than SNMT. On the other hand, the higher this number is, it means that macro F1 prefers UMT more than SNMT, while BLEU prefers SNMT way more than UMT. So we look at these two extremes and see what metric makes more sense. So we found these two characteristics for macroF1. It punishes on translations and truncations more. So here is the example where macroF1 punishes on translations. So the highlighted word is in the source and it's just copied to the to UMT's translation. And macroF1 prefers SNMT, while BLEU thinks this is not that big of a problem and prefers UMT. As you can see, the BLEU, the delta BLEU is negative, which means it prefers UMT. So I'm thinking this might be because macroF1 has equal weights for each word. So even though this on translation is a really rare word because it's not even supposed to be in this English vocabulary.
It's actually just a compound, right?
What?
It's a compound. Pflege, care, and Versicherung. So German has a lot of compounds that are spelled together.
Yeah.
So that's the source of the issue there.
Oh, but I think because we use BPE, the bipair encoding, so this word is actually divided into subwords. Even though there is compound, it can still be translated to different words in English.
Okay.
Yeah, so I think the compound might not be the whole issue. I'm not sure. But yeah, thank you for the question. Yeah, so because these words have the same weight as the other words, macroF1 detected that it shouldn't have this word and will give more weight. Will give more score to SNMT, which doesn't have these translations. And this example is where macroF1 favors the sentence without truncation. We can see in the reference that the highlighted second half of the sentence just wasn't anywhere in the unsupervised machine translations output. Yeah, so when there is a truncation, it's very likely that there are content words in the truncation, and then those content words will have play more weights in the macroF1 than BLEU. But we can see that BLEU still prefers UNMT. But there are also two good things about BLEU that we discovered. The first one is that it punishes different word order. So this is good when the different word order does affect the translation meaning. But it also plays the opposite effect when the word order doesn't affect translation meaning, but BLEU still punishes for that. And the second thing is that it doesn't punish synonym of content words more than other high frequency words. So both BLEU and macroF1 are not learned metrics, so they cannot really know if this word is a synonym of the reference or it's actually a wrong word. So BLEU doesn't punish synonym that much. So this is an example of where different word order affects translation meaning. So it says he and Molinari dubbed Mollywood. So dubbed Mollywood describes he and Molinari. But in SNMT, the word order is changed, and it describes after a sensational weekend, which definitely is wrong in this case. But BLEU can figure out this difference, and BLEU says UMT is better in this case. Also, so for the synonyms, here we can see that the highlighted words are synonyms in SNMT. But macro-F1 will claim that these words are not the right words, and they have more weights on these words. So, but if we actually examine the sentence, we can see that the SNMT translation is has the same meaning as the reference, and UMT has more problems. But in this case, BLEU can be a better judgment. So after seeing the benefit of SNMT and what significant progress we can make with just monolingual data already, we want to know how we can make best use of all data. In the data abundant case, we have UMT trained with 5 million data and SNMT trained with 1 million data. So this is in German English. So macro F1 is much higher for SNMT. But if we just fine-tune the UMT model on the 30,000 parallel data, although BLEU doesn't change much, macro F1 is boosted 2 points already. And if we train with more parallel data, we fine-tune with just a bit more parallel data, it can make it almost match SNMT in macro F1, while BLEU also surplus SNMT. Also, UMT has around 6.5% of untranslations, while SNMT only has 4.1%. After just 30K parallel data fine-tuning, UMT's untranslation decreases to 4.6%. Also, after just 30K fine-tuning, UMT's word accuracy in low frequency words also increases. So we can see that it's better than SNMT as low as frequency of 3, while it used to be already lower than SNMT when it's the words have frequency of 10. Also, sentences that are longer than 60 words have higher BLEU scores than before. We also did an ablation comparing different combinations of UMT and SNMT with relatively low data, 30K parallel data and 500K monolingual data in German English. The result aligns with XLM's result that first pre-training with MLM, the mass language model, and then train with both supervised MT and back translation gives the best result. So this highlighted number is that. So this is just 2 to 3 BLEU lower than training with 5 million monolingual data unsupervised or 1 million parallel data supervised. What we are curious is that adding a UMT step between MLM and SNMT plus back translation will make the performance worse. So we can see if we add that in the middle, BLEU drops to 22. So we don't know why this is the case yet, but we hope to see if it's the same on other different language pairs. In summary, UMT and SNMT are different qualitatively, as UMT has more untranslations, higher BLEU at medium length sentences, and higher word accuracy at high frequency words. We also showed that macro F1 and BLEU focus on different properties. Macro F1 punishes untranslations and truncations, while BLEU punishes word order differences, which is good when the word order does affect the meaning. And it does not punish synonyms more than other words, giving more flexibilities in words. And we should definitely use all available data, no matter it's supervised or unsupervised, once in low resource settings. Some continuing work is quantifying more qualitative differences between both UMT and SNMT and macro F1 versus BLEU. Also, we want to compare Pashto and other more distant languages to see how we can best combine SNMT and UMT. Thank you.
Thanks. Are there any questions from the audience or any comments as well? Feel free to leave a message in the chat, or you can just speak it out loud. Or John, if you have any questions about, if you have any comments about this work, feel free to add.
No, I thought it was great work, but it helped with Weiqiu, so the things open for other people's questions.
This is Ulf. If you could maybe share the slides, I'd be interested to actually look at some of the examples in more detail, since there were a lot of cool German English examples.
Yeah, sure, of course. Oh,
if you share with me, I can distribute it to the list too.
I can share it now if you want to look.
Excellent.
Any other questions from the audience?
Yeah, I wanted to ask a question.
Yeah.
Hi, I'm Katie. I'm a new PhD student. I started this week.
Yeah, we met.
And I was wondering, so you said you don't really know yet why adding a unsupervised step into the pipeline actually makes it worse. And I was wondering if you like have any like guesses or hypotheses you want to test on why that might be.
I'm thinking one thing might be it's over like it overfits on the unsupervised, and it's harder to learn from the supervised and plus back translation. But I'm not sure how to test that yet.
What's kind of interesting is that, I mean, if you just obviously if you just do MLM by itself, that's not a translation model, so that can't translate anything.
Yeah.
And if you do UNMT from scratch, or even SMT plus BT from scratch, those are having something prior is better. It's kind of like the MLM. The MLM is trained on much more data than the UNMT, right?
Oh, it's the same amount of data.
Oh, it's the same. Okay, it's not some cushion. Yeah, it's very confusing.
Another thing I'm thinking is maybe I should decrease the learning rate, as it's already trained with UMT, and maybe when fine tuning it needs a smaller learning rate. But I did that with some other experiments, and different learning rate doesn't really matter. Yeah, so I'm not very sure.
I think you may want to try it with other languages to see if this is just kind of, sometimes you get weird stochastic variance. You can try significance testing too, do a pair of bootstrap on the test set to see how much variance you should expect.
Yeah.
There's a question in the chat that says, what was the error annotation scheme used in the study?
So actually it's basically me looking at those examples and just write down some problems that I see, and if it's if they are similar, I might group them together. And so I annotate those problems with an underscore at the beginning when this is not a real problem, and when I don't annotate it with the starting with the underscore, that it means that it's a real problem. But I guess this is just a small analysis, but if we want more rigorous analysis, we might want like having more people to annotate it, or but it's just it's really hard to quantitatively look at it like automatically. So
kind of a follow-up. It looks like you are able to annotate these. And so do you think it would be possible for it to be annotated? Like if you sort of have enough annotations to build some sort of classifier or something?
yeah, maybe. Maybe I can like annotate some more and then build a classifier to annotate the whole thing. Another thing I'm thinking, there's a tool called linguistic, which is, but that's for English German only. So it has some comparable contrastive data pairs. So it can analyze different different linguistic qualities, but that's for English German only. So I'm not sure if it's it can be used for other languages and stuff.
Cool. Any more questions from the audience or comments? If not, I was sort of wondering, like keeping all these findings in mind so far, what would be your overall takeaways or recommendations for both BLEU and this macro F1 and just like qualitative analysis? Like, do you think these could sort of be used together or should be used together? Or do you think one is more important than the other or anything like that?
I guess for BLEU and macro F1, a lot of other works that show that BLEU has weaknesses and should be replaced with by other metrics. So I feel like when we are evaluating the machine translation models, we shouldn't just use BLEU, but maybe look more qualitatively and use a couple different metrics when evaluating. And for UMT and SNMT, the main takeaway I think is so UMT still even when they have the same BLEU, it still has some more problems, and what we want to try to find out is how to best combine the monolingual and parallel data. That's still continuing work, and I think just using UMT might not be the best idea because it's not if we have some even if there's a small amount of parallel data, we can combine both UMT and SNMT and I'll have much better performance. Yeah, so mainly just we should make use of available data.
Cool, thanks. Any other questions or comments? All right, if not, then we will, oh, go ahead.
Well, I wanted to thank there's a few guests, like former interns or immediate previous interns, and I wanted to thank people from out of quote unquote out of town for coming to the talk today, and encourage you to come to more out of town talks so that we can have them more easily. And tell your friends.
Awesome, thanks. Yeah, so with that, if we have no other questions or comments, we will conclude this talk. And thank you everyone for coming, and thank you, Rachel, for presenting. Yeah.
Yeah.
Bye-bye.